Yes, a very good afternoon to one and all. Once again, I'm here to present a new topic today, that is Unit 5 Transportation Problem, students. So this is all about how do you transport from the source to the destination with the less transportation cost, okay, minimum transportation cost. So here there are three methods, as I've told you in my previous theory explanation, that is northwest corner route, least cost method, and the third one is Vogler's approximation method. So we are going to learn three kind of problems, and now let's see with the first method called northwest corner route, okay, which is also called as NWCR. Okay, so this is a method which we are going to go ahead with. Okay, it's very simple and easy. This D is nothing but destination, S is nothing but the source here. Okay, and demand as well as supply is given. Now there are certain steps which you need to follow for this problem. The first step here is step 1. I have already given you these steps in my theory part, but still I am explaining you with the steps. That is to check demand is equal to supply. First you need to check this condition, students. Is demand equal to supply? First condition or the first step. Okay, it happens at certain times where you see demand is not equal to supply. Whenever demand is not equal to supply, you need to add a dummy row or a dummy column, that is nothing but zeros, which will make it equal. Okay, and then you need to move forward with the problem. We will see such kind of a problem also, but just we will see with the simple problem first. Okay, so you need to add, that is 5 plus 8 is 13 plus 7 is when I total sum it up, it comes to 34. Okay, if I total it up, it coming to 34 when I add everything. Okay, so 13 plus 7, so it becomes 21 and then 14. Okay, so then next similar way I need to add these three values. So again it becomes 34. Okay, so here when we see both demand and supply are equal, that is 34 is equal to 34. Okay, so the step 1 condition is satisfied. Now I write here 34. Okay, students, so this is how first step we have calculated. Then the second step, step 2. Okay, so what you need to do here is, that is what is the calculation which we will be doing it. It is all included in that. You have to come up with the allocation. The symbol for allocation here is this, square braces. Okay, so here this is your second step, that is you are coming up with allocation. Okay, here this is a symbol for allocation. Okay, students, so here what you need to do is, you have to put an allocation. This is northwest, so you have to take the topmost north and west value. So 19 is the topmost north and west corner, so I put the allocation here, and I need to check demand and supply. Okay, so here demand is 5, supply is 7. So you need to take the minimum value, that is I am allotting here, allocation is 5 here. So I will strike 5, it becomes 0. So the demand is done. And here if I subtract 7 minus 5, I will get 2. So I am striking 7 and writing here 2. Okay. So once the allocation is done, wherever you are getting 0, strike that row or column. Okay. So because it is 0, I am striking this column. Now, don't consider this now. It's over, this part. The next northwest is 30. Now, you need to check demand and supply. Okay, so the minimum value is 2 here. Okay, I am writing here 2. It becomes 0. Supply becomes 0. Then here, that is 8 minus 2 will become 6. Okay, so because it has supply has become 0, I am going to strike this row. Done. You are not going to consider row again. The next remaining these 6 values, among them the north and the west value is next 30. So I put the allocation there. Now again I have to check demand and supply. It is 6 and 9. So the minimum value here is 6. So I allocate here 6. So this 6 becomes 0. 9 minus 6 will become 3. Okay students, so here we get the value as 3. Then because it has become 0 now, I am going to strike this column. Okay, now left these 4 values. Okay, now the allocation will come for this north west value. Here 40 is the value for allocation. I need to check demand and supply. It is 7 and 3. The minimum is 3. So I allocate here 3 and cancel this 3, mark it 0. Then 7 minus 3 is 4. So I write it here 4 and cancel this row. Okay, then the next is left is 70. I put the allocation there. Then you have to check demand and supply. It is 4 and 18. So I write minimum value as 4. This becomes 0. 18 minus 4 is 14. Okay, so here this becomes 0. I strike this column. Remember students, always if you are doing the problem, mark it in mind that whenever the last value comes, here both demand and supply should be equal. If it is not coming equal, then you are making mistake with your calculation. It should be always equal. So the leftover value is 20 here. I am putting the allocation for this, and here 14 and 14. So I take here 14 in the allocation, 0 and 0. That means your demand and supply is satisfied. Okay, so this is how you need to calculate. This is only step 2. Okay, this is step 1 and this is step 2. The whole calculation part is step 2. Okay, then next step.
Next slide.
Step 3. Here step 3 is to check if IBFS is satisfied. What is IBFS? It is initial basic feasible solution. Okay students, So there is a formula for this IBFS, that is m plus n minus 1, that should be equal to number of allocations. Here number of allocations should be equal to m plus n minus 1, where m is rows, n is columns. Okay students, so here you need to count first. How many allocations are there? 1, 2, 3, 4, 5 and 6. So here there are 6 allocations. Okay students, should be equal to m, that is rows. How many rows are there? 1, 2, 3. Don't consider demand and supply. You need to only consider the source, okay, as the row. That is 3 plus, how many columns are there? 1, 2, 3, 4. 4 minus 1. Okay students, so it is 3 plus 4 minus 1, so it becomes 7 minus 1. So 6, 7 minus 1 is 6. Therefore both the allocations and the row plus column minus 1 both are equal. Therefore IBFS is satisfied. This is your step 3. Okay, now IBFS is satisfied. Now step 4. Is to calculate total transportation cost. Okay, so you need to calculate the total transportation cost. Okay, this is your step 4. Yeah, how do you calculate the transportation cost? Here is the value into allocation. Okay, that is 19 into 15. Okay, like that. Next 30 into 2. Whatever, when you sum up the total cost which you are getting is nothing but your optimal solution or optimal transportation cost. Now let's calculate. First we will note down what are the values we are able to get it. That is 19 into 5, 30 into 2, 30 into 6, then 40 into 3, 70 into 4 and 20 into 40. Yes. Now let's see what is the total values we are getting. So 19 into 15 is, 5 is 95. 30 into 2 is 60. 30 into 6 is 120. 40 into 3 is 120. Sorry, 80. 180. 120. And here 70 into 4, 280. And 20 into 14 is 280. Now if I sum this value, I would be getting it as 4,050. 50. Okay, that is 1015 is the total value. So Therefore, the optimal transportation cost is 1015. Okay students, it is 1015. Okay students, so this is the way to calculate northwest corner route for transportation problem. I hope you students have understood and practice more of such problems for a better understanding. Have a great day all. Thank you.